Okay, now I have the right poster. So we've got the CG of the boom, the line of force going straight down. The shortest distance between the line of force and the pivot point is what we want. That's our distance. So we've got a right triangle again, but the hypotenuse is 22 inches. We still have 70 degrees. So the cosine of 70 degrees is 3.42. Everything's the same except instead of 45 we have 22 inches. A little algebra. The distance is 7.52 inches. Remember, weight times distance. So we take the distance, 7.52 times the weight of the boom, 2.2 pounds, and get 16.54 inch-pounds. Now we have to combine both the torque of the load, 72, and the torque of the boom. Combined gets you 88.87 inch-pounds, which is more than 84. So it should be tipping over even at 70 degrees, but it's not. Why, you ask? The numbers are ideal. The weight of the crane is 7 pounds, give or take. The length from the fulcrum to the center of gravity is 12 inches, give or take. All these measurements are not very exact, especially the weight. The scale I have to weigh things is far from accurate. So the whole concept is that we want to find the torque on both sides of the fulcrum. Now, according to the numbers here, it should be tipping over even at 70 degrees. This is greater than this, but it's not because all the measurements are not quite perfect. But you get the concept. You got to figure out the torque of the crane versus the torque of the boom and the load on the other side. And that all changes. Well, I tell you what, let's make believe we went down to 60 degrees on the boom, and you know it's going to tip over. What can we do? How about counterweight? So before we, well, that's the next video. Stay tuned.